Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we discuss about the wave nature of light. Wave nature of light. Okay. Light is a transverse electromagnetic wave. So transverse, it's nothing right. If the light rays are traveling in one medium, the direction of the particles at that medium is perpendicular to the direction of the wave. So like this, waves are called the transverse waves. So here light is a transverse wave. Electromagnetic wave also travels like a transverse. The wave nature of light was first illustrated through experiments on interference and diffraction. The wave nature of light was first illustrated through experiments on the interference and diffraction. So interference, it's nothing but if two light rays are released from coherent source, these two light rays are superimposed at one point. At this point, we have two different areas. In one area, there is high intensity region. In another area, there is a low intensity region. So this total process is called interference. Next, diffraction. The light rays usually flowing in a straight line. There is any obstacles are faced by the light. These lights are cross these obstacles at the edges by bending of its path. The light rays are travel by bending of its path through the sharp edges of the obstacles. So this is the process of diffraction. Like all electromagnetic waves, light can travel through vacuum. The transverse nature of light is demonstrated in polarization. So polarization means unpolarized light is converts into polarized light. So that is the polarization. Next, wave optics. Wave optics deals with wave characteristics of light with the help of wave optics. So wave optics deals the wave characteristics of the light. So light propagates as a wave. Its direction of propagation is still represented as a ray. Now look at here. If any stone or any body is placed on the surface of water, you understand the wave structure is generated on the water surface. An example for wave propagation is the spreading of circular ripples on the surface of still water from a point at which a stone is dropped. An example for wave propagation is the spreading of circular ripples on the surface of still water. So from a point at which stone is dropped. The molecules or particles of water are moving only up and downs when a ripple passes out that part. The molecules or particles of water are moving only up and down when a ripple passes out that part. All these particles on the circular ripple are in the same phase of vibration as they are all at the same distance from the center. So here ripples are generated at one point. Here the same distance is generated for that vibrations from the center. The ripple represents a wavefront as shown in the figure. So ripples represents the wavefront. So look at here, wavefronts diagram. There is a two types of wavefronts are there. First one is spherical wavefront. Second one is linear wavefront or parallel wavefronts or plane wavefronts. We use a ray to indicate the direction of motion of the wave. We use a ray to indicate the direction of motion of a wavefront. The rays of a circular wavefront are radial lines. The rays of a circular wavefront are radial lines. So the rays of a plane wavefront are parallel lines. For plane wavefront, the lines are parallel. For circular wavefront, the lines are radial lines. So this is the direction of motion of a wavefront, like a ray. A wavefront is the locus of points which are in the same state or phase of vibration. So simply, wavefront is the locus of points which are phase of vibrations. When a wave propagates, it is treated as propagation of wavefront. The wavefront is always perpendicular to the direction of propagation of the wave. So wavefront is always perpendicular to direction of the wave. As the direction of wave is in the direction of propagation of the wavefront is always perpendicular to the ray as shown in the figure. So before that figures, you observe the direction of propagation of wave, wavefront is always perpendicular to the ray. So this is the information about the wave nature of the light. So here we discuss the simple wavefronts and rays At the same time, the ripples formed in the water surface and how to represent the wavefront. So this is the information about wave nature of light. So thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thank you.